Hi friends, welcome back on our YouTube channel. In today's lecture of classical mechanics, we will discuss about conservation laws and symmetry. As we know, there are three types of conservation laws: conservation of linear momentum, conservation of angular momentum, and conservation of energy. All these three conservation laws we have already discussed in our earlier lecture. Now here we will discuss about conservation laws based on symmetry. So conservation laws and symmetry. Here we will discuss about concept of symmetry, that is homogeneity and isotropy, conservation laws and symmetry, conservation of energy, conservation of linear momentum, and conservation of angular momentum. These 5 topics we will discuss in this lecture. Now, first of all, concept of symmetry, that is homogeneity and isotropy. So, concept of symmetry. If any system or any function representing a property of the system does not change under some operation, then the system is said to possess a symmetry with respect to the given operation. So, if on doing some operation the system does not change the property, then the system is said to possess a symmetry with respect to that particular operation. For example, when a cylinder is rotated about its axis by any arbitrary angle, its apparent shape does not change. Suppose here we have a cylinder. Now, if we rotate it by any arbitrary angle about its axis, then its shape does not change. So, the cylinder is said to have rotational symmetry about its axis, because on rotating this cylinder about its axis, it does not change its shape. So, the cylinder is said to have rotational symmetry. Now, closed system. What is closed system? A closed system is that system which is not acted upon by any field of force and whose source is external to the system. So, such type of system is known as closed system. A closed system is that system which is not acted upon by any field of force and whose source is external to the system. Now, first of all, homogeneity of space. Now, what is homogeneity of space? If for any arbitrary displacement of the origin of any reference frame, the physical properties of all closed systems remain unaffected, the space is said to be homogeneous. So here we give an arbitrary displacement to the origin. So if for any arbitrary displacement of the origin of any reference frame, the physical properties of all closed system remain unaffected, means the physical property does not change. When its origin have an arbitrary displacement, then the space is said to be homogeneous. Now, second one is isotropy of space. What is isotropy of space? If for any arbitrary rotation about the origin of any reference frame, the physical properties of any closed system does not change or remain unaffected, the space is said to be isotropic. Here we are giving any arbitrary rotation about the origin of any reference frame, and in doing this operation the physical properties of the closed system does not change, then the space is said to be isotropic. Now third one is homogeneity of time. What is homogeneity of time? If for any arbitrary displacement of the origin of time, the physical property of any closed system remain unaffected, the time is said to be homogeneous. So in homogeneity of time, we are giving an arbitrary displacement of the origin of time and the property of the system does not change. In isotropy of space, we are giving an arbitrary rotation about the origin of any reference frame and the physical property of the closed system does not change. And in homogeneity of space, we are giving an arbitrary displacement of the origin of any reference frame and the physical property of the system does not change. Now, conservation laws and symmetry. First of all, homogeneity of time and conservation of energy. So here, we will show the conservation of energy on the basis of homogeneity of time. So homogeneity of time and conservation of energy. What do you mean by conservation of energy? According to conservation of energy, the energy can neither be created nor be destroyed. It can only be changed from one form to another. Now, we will show the law of conservation of energy on the basis of homogeneity of time. Homogeneity of time means the Lagrangian of the closed system should not have any time dependence, or the Lagrangian is invariant under time translation. So, if we give an arbitrary displacement to the time, the Lagrangian of the system does not change, then the system have the homogeneity of time. It is related to the conservation of energy. So homogeneity of time is related to the law of conservation of energy. Now we prove it. Let there be a small time displacement delta t and let the change in Lagrangian L corresponding to this small time displacement be delta L. So we are giving a small time displacement delta t and the change in Lagrangian corresponding to the time displacement delta t be delta L. So L is changed by delta L when t is changed by delta t. So delta L equals to del L by del t into delta t. Since the time is homogeneous, so the Lagrangian of the system should not change. So Lagrangian of the system remains constant because the time is homogeneous. For t equal to t plus delta t, delta L equals to 0. It means here we are changing time by a small value, but the Lagrangian of the system remains same. That is, the change in Lagrangian is 0. So delta L equals to 0 if t will be t plus delta t. But delta L equals to del L by del t into delta t and delta L equals to 0. It means del L by del t into delta t equals to 0 or del L by del t equals to 0. Now it is clear from here that L does not change with respect to time because the differential of L with respect to t is 0. It means Lagrangian of the system does not explicitly depend on time, or Lagrangian is independent of time. So del L by del T equals to 0. It means the Lagrangian of the system does not explicitly depend on time. Since the Jacobian J represents the total energy is represented by Jacobian, and Jacobian is PIQI dot minus L. Now, if we differentiate J with respect to time, it means dJ by dt equal to d by dt of PIQI dot minus L. So, we differentiate PIQI dot minus L with respect to time. So, what will it? We differentiate PIQI dot with respect to time. So, Pi is constant and differential of QI dot is QI double dot plus QI dot is constant here and differential of Pi is Pi dot and the differential of L is dL by dt, or d by dt of Pi QI dot minus L is, first of all, Pi is constant and differential of QI dot with respect to time is QI double dot. Second time, QI dot is constant and the differential of Pi with respect to time is Pi dot minus differential of L is dL by dt, and L is function of QI dot and T. It means L is a function of coordinate, velocity and time. Now, dJ by dt is this one. Now, if we differentiate L with respect to time totally, means what is dL by dt? dL by dt is equal to del L by del T plus del L by del Qi into Qi dot plus del L by del Qi dot into differential of Qi dot with respect to time, that is Qi double dot, and here we have negative sign. So minus dL by dt will be minus del L by del T minus del L by del Qi into Qi dot minus del L by del Qi dot into Qi double dot. So this will be dL by dt. For a closed system, all the component of external force are 0, including the non-potential terms, that is capital Qi dash is 0. So for a closed system, all the component of external forces are 0. So Euler-Lagrange's equation of motion is d by dt of del L by del Qi dot minus del L by del Qi equals to 0. This is our Euler-Lagrange's equation of motion. Since Pi equal to del L by del Qi dot, so if we replace it by Pi, then d by dt of Pi, that is dPi by dt, is equal to del L by del Qi. So here we transfer this term from here to here and we replace del L by del Qi dot by Pi. So dPi by dt equal to del L by del Qi, and dPi by dt means the rate of change of Pi with respect to time is Pi dot. So Pi dot equal to del L by del Qi. But dJ by dt is this one. Pi is del L by del Qi dot and Pi dot is equal to del L by del Qi. Now we replace this del L by del Qi by Pi dot. So this term will be minus Pi dot Qi dot, and del L by del Qi dot is replaced by Pi. So this term will be minus Pi Qi double dot. Now Pi dot Qi dot will be cancelled with Pi dot Qi dot, and Pi Qi double dot will be cancelled with Pi Qi double dot. So dJ by dt equal to minus del L by del T. and del L by del T equals to 0. So this will be 0. It means dj by dt equal to 0. So dj by dt equals to 0. And if the differential of any physical quantity is 0, then that particular physical quantity will be constant. It means j equal to constant. So j equal to constant, and j is actually Jacobian, and Jacobian represents the total energy. It means the total energy remain constant, and it is our law of conservation of energy. Thus, the total energy of the system is conserved. So, here we prove the law of conservation of energy on the basis of homogeneity of time. Now, next one is homogeneity of space and conservation of linear momentum. According to the law of conservation of linear momentum, in the absence of external force, the total linear momentum of the system remains constant. And now, we will prove the law of conservation of linear momentum on the basis of homogeneity of space. So homogeneity of space and conservation of linear momentum. Now what is homogeneity of space? Homogeneity of space means the Lagrangian of a closed system should not change due to arbitrary small uniform translation for all the particles. So, on giving arbitrary translation to the particles, the Lagrangian of the closed system does not change. It means it is actually the homogeneity of space. And homogeneity of space is related to the conservation of linear momentum. Now, we prove it. Let Ri be the position of ith particle and let it move by delta Ri. Ri is the position vector of ith particle and it move by delta Ri. It means here we are giving a small displacement to the position vector of ith particle. So, Ri become Ri plus delta Ri. Let the change in Lagrangian L corresponding to change in R, that is delta Ri, be delta L. So, Ri is changed by delta Ri and the corresponding change in Lagrangian is delta L. And delta L equals to del L by del Ri into delta Ri. Since the space is homogeneous, so for any arbitrary translation delta Ri, L does not change or delta L equals to 0. So, for Ri equal to Ri plus delta Ri, delta L equals to 0. And delta L equals to del L by del Ri into delta Ri. And delta L equals to 0. It means del L by del Ri into delta Ri equals to 0. So, del L by del Ri into delta Ri equals to 0. Or del L by del Ri equals to 0. It means L does not change with respect to displacement Ri. It means the Lagrangian of the system does not explicitly depend on position. So Lagrangian does not explicitly depend on position of the particle because the differential of L with respect to Ri is 0. So Lagrangian is constant with respect to position. Now, Euler-Lagrange's equation of motion for the conservative system is d by dt of del L by del Ri dot minus del L by del Ri equals to 0, and del L by del Ri dot equal to Pi. So this value is replaced by Pi, and del L by del Ri equals to 0. So dpi by dt equals to 0. So this is replaced by Pi and this is our 0. So dpi by dt equals to 0. It means linear momentum does not change with respect to time. So dpi by dt equals to 0. Now for whole system, sigma I Pi dot equals to 0, because dpi by dt equals to Pi dot. So for whole system, sigma I Pi dot equals to 0, and Pi dot is 0, it means Pi is constant. So sigma I Pi equal to constant, it means the total linear momentum of the system remain constant, or the total linear momentum of the system conserved. Thus, due to homogeneity of space, the total linear momentum of any closed system remain constant or remain conserved, and it is the law of conservation of linear momentum. It means the law of conservation of linear momentum is related to the homogeneity of space. What is law of conservation of linear momentum? In the absence of external force, the total linear momentum of the system remain constant or remain conserved. Now next one is isotropy of space or conservation of angular momentum. What is law of conservation of angular momentum? In the absence of external torque, the total angular momentum of the system remain constant. Now, isotropy of space and conservation of angular momentum. Since in isotropy of space, the Lagrangian for a closed system should not change due to any arbitrary small rotation of reference frame about some direction. So here we are giving a small arbitrary rotation to the system, and the Lagrangian of the closed system does not change. Isotropy of space is related to the conservation of angular momentum. Now, how it is related to conservation of angular momentum? We will prove it here. Now, proof. Let delta A be the change in any vector A by an arbitrary small rotation delta theta about some direction passing through origin. So, here we are giving an arbitrary rotation delta theta, and in this rotation vector A is changed by delta A. So delta A will be delta theta n cap cross A, and this delta theta is arbitrary rotation to the system, and delta A is the change in A. Therefore, for position vector, delta Ri will be delta theta n cap cross Ri. Here we have A, then delta A, and if we have here Ri, then this will be delta Ri. So for position vector, this equation will be this one. Now delta Ri is delta theta n cap cross Ri. Therefore, for velocity vector, delta Vi will be delta theta n cap cross Vi. So this Ri is replaced by Vi, then this will be delta Vi. So for velocity vector, this equation will be delta Vi will be delta theta n cap cross Vi. Let delta L be the change in Lagrangian L if the change in position is delta Ri in Ri and the change in velocity is delta Vi in Vi. So velocity is changed by delta Vi, position is changed by delta Ri and L is changed by delta L. So delta L equals to del L by del Ri delta Ri plus del L by del Vi into delta Vi. From Euler-Lagrange's equation of motion. Now what is Euler-Lagrange's equation of motion? D by dt of del L by del Ri dot minus del L by del Ri equals to 0. And del L by del Ri dot is actually Pi. So this will be replaced with Pi. So dpi by dt is equal to del L by del Ri. And what is Pi? Pi is linear momentum. And dpi by dt is Pi dot. So Pi dot equal to del L by del Ri. Now delta L is this one. Delta Ri is this one. And delta Vi is this one. Also, Pi equal to del L by del Ri dot, and Ri dot means the rate of change of position, which is actually Vi, that is velocity. So Ri dot will be Vi. It means Pi equal to del L by del Vi. Also, Pi dot is del L by del Ri. Now, this del L by del Ri is replaced with Pi dot. So Pi dot. Delta Ri is replaced with delta theta n cap cross Ri. So delta theta n cap cross Ri plus del L by del Vi is actually Pi. So this will be replaced with Pi. So Pi. And delta Vi is this one. So delta theta n cap cross Vi. So delta L will be this one. For whole system, delta L equals to delta theta will be taken as common. So delta theta sigma I Pi dot n cap cross Ri. So Pi dot n cap cross Ri plus Pi n cap cross Vi. So Pi n cap cross Vi. So this is our delta L. Now d by dt of Ri cross Pi dot n cap means we differentiate it with respect to time. So d by dt of Ri cross Pi is dRi by dt cross Pi plus Ri cross dpi by dt and n cap as it is. So here we apply u into v method. So differential of Ri cross Pi is dRi by dt cross Pi plus Ri constant cross dpi by dt. So we get this value. But dRi by dt is Vi. So Vi cross Pi n cap and dpi by dt is Pi dot. So Ri cross Pi dot n cap. So d by dt of Ri cross Pi dot n cap will be this one. Or this will be equal to n cap cross Vi into Pi plus n cap cross Ri into Pi dot. Now Pi dot can be transferred here. So Pi dot n cap cross Ri plus Pi can be transferred here. So Pi n cap cross Vi. So this quantity will be this one. Now delta L is this one. d by dt of Ri cross Pi dot n cap is this one. Now, Pi dot Ni cap cross Ri equal to d by dt of Ri cross Pi dot n cap. This value will be transferred here. So minus Pi n cap cross Vi. So Pi dot n cap cross Ri is this one. Now we replace this Pi dot n cap cross Ri with this one. So delta L equals to delta theta sigma I. This value is replaced with this one. So d by dt of Ri cross Pi dot n cap minus Pi n cap cross Vi, and this term as it is, so plus Pi n cap cross Vi. Now this term and this term will be cancelled out. So delta L equals to delta theta sigma I d by dt of Ri cross Pi dot n cap, or we can directly replace this term with this one. So delta L equals to delta theta sigma I d by dt of Ri cross Pi dot n cap. Due to isotropy of space of a closed system, the Lagrangian of the system does not change, that is delta L equals to 0. So delta L is 0. It means delta theta sigma I d by dt of Ri cross Pi dot n cap is 0. Now we get this term. For any arbitrary rotation, delta theta is not equal to 0. So this is not equal to 0. So definitely sigma I d by dt of Ri cross Pi dot n cap will be 0. So sigma I d by dt of Ri cross Pi dot n cap is 0, or d by dt of sigma I Ri cross Pi equal to 0, and d by dt of sigma I Ri cross Pi is 0. It means sigma I Ri cross Pi will be constant, since Ri cross Pi is the angular momentum of ith particle, and here L is already used for Lagrangian, so we use J for angular momentum. So angular momentum of ith particle, that is Ri cos Pi, is Ji. This is our Ji. So sigma I Ji is constant, and sigma I Ji is total angular momentum of the system. So total angular momentum of the system remains constant, or the total angular momentum remains conservative. Thus the total angular momentum of the system remains constant or conservative, and it is the law of conservation of angular momentum. So here we end our session. In today's session we have discussed about conservation laws and symmetry. So goodbye.